Hello, everybody. My name is Rafael Trinidad, and thank you for having me here today. I would like to discuss an issue in my personal field of study, robotic engineering, and more broadly, just engineering in general, because this problem follows all through engineering. So, as an engineer, you are taught to find problems and fix them, generally, usually by creating some tool or machine or part that's meant to make the problem easier to deal with or removing the issue altogether. When you find an issue that you intend to fix, you see it as the world would be better without this problem, so therefore you should remove it. Factories caused production to be faster, plastic made fabricating materials cheaper and easier, and the iPhone connected the world and made us more streamlined and efficient. However, these inventions have already been properly integrated with our society and do not cause more trouble than what they're worth. However, things like electric vehicles, solar panels, and other inventions along those lines that sound good on paper do not necessarily always work on a large scale in our society because of a lack of one thing: standardization. So, to understand how lack of standardization can hinder progress, take a look at a technology that has already been applied for a while now: solar energy. In a paper posted to Science Direct, the author highlights how the fluctuations in energy that occur when RES, or renewable energy sources, are added to a traditional power grid make it hard for them to be used, especially at the transmission level where power is already being sent at full capacity. This hinders the integration of RESs in the power network and conversely affects the dire global need for a sustainable energy sector. So, to put that simply, during the day when most solar energy is being produced, obviously, because you have the sun directly over you, our power grid is unable to handle that excess energy because we don't have the facilities needed to be able to store it. This is because we still heavily rely on getting energy from power plants such as nuclear plants, coal plants, hydroponic dams, other stuff like that, fossil fuels, petroleum. So, our lack of support for energy gained from solar, or the lack of standardization for solar power, makes the objectively efficient form of gaining energy from the sun a hindrance. Ideally, we would be getting a vast amount of our energy from solar, but this would make fossil fuels nearly obsolete, and we as a society, globally, rely heavily on fossil fuels to still power our factories, cars, motors, engines, anything like that, manufacturing plastics. That all plastics are fossil fuels, and they make up probably 90% of the material used in consumer products today. In a report from the United States Energy Information Administration, renewable energies like solar and wind only make up about 9% of our total energy production. Fossil fuels make up almost 88% of that energy, and the rest of it comes from nuclear power plants. The takeaway from this is that even though fossil fuels will one day dry up, currently it is being used as a crutch for the entire world, as most of the world does not have the infrastructure to support renewable energy sources. And this is the issue with the lack of standardization. So, standardization serves four main purposes: safety, consistency, efficiency, and interchangeability. Another example that I can think of is how, up until Apple was sued recently, iPhones needed the specific Apple Lightning cable to charge. I'm sure you all remember that. And this caused issues because the charger was only able to use for the iPhone, nothing else. Therefore, it was not consistent with industry standards. It was not efficient since they had to personally manufacture every one of those chargers themselves. Since nothing else in the world used them, they couldn't buy them from another company that makes them, and was not able to be interchanged with another product that the consumer owned. You couldn't use it to charge your headphones, you couldn't use it to charge your computer, nothing. It was only for the iPhone and maybe your AirPods. This caused them to own pretty much a monopoly on this product, and now, after they've been sued, all iPhones have changed over to USB-C chargers, which is now the industry standard. The idea is the basis for why standards are important in the engineering field and the consumer field. It's why most screws are either Phillips head or flathead, why all internet driven devices have to be able to be used on the same Wi-Fi bands, and even as simple as shows and movies being recorded in an aspect ratio that is able to be comfortably watched on most consumer televisions. So it is important to have standards because if we did not, any company would have to manufacture all of their own parts, which would make products more expensive, very more expensive. And you, as the consumer, would be required to research which items work with each other when shopping for things such as televisions or even a new car. So you would need to have all your electronic devices, they would all have different charging cables. All the cables wouldn't be able to plug into the same outlet. You'd have to have different outlets in your house. So stuff like that. It's why we have standardization. It's why all houses in America have the same kind of charging ports that you're able to plug into. That's what standardization is. Another issue that a lack of standardization causes is that a new idea can be made useless as we are either ignorant towards the necessity for change or have already invested so much in another method that it would be more of a waste to change it now. This is harmful because it inhibits ingenuity and demotivates the next big idea. If a new breakthrough in technology occurs, it takes the world decades to be able to even use the technology, let alone standardize it. Say we make a breakthrough in automotive technology, where we manufactured a better and more efficient wheel. However, it is not able to be installed on the standard car since it's designed differently. Well, this just makes the new and better wheel, the objectively new and better wheel, completely obsolete because it would require us to completely redesign all the cars, and then everyone in the world has to own those cars so that they can buy this product so we can make a profit off of it, and that just doesn't work. It's too much money, it's too much pressure, too much trouble for what it's worth. So when engineers try to design a new product or part, they need to constantly keep in mind industry standards. And this can inhibit what they could potentially make. Not only this, but whenever you do try to break the norm and create a completely new product, the cost is extremely high. This is because instead of being able to interchange parts and upcycle old parts, every individual part has to be designed, manufactured, and tested in of themselves. This can also serve to inhibit ingenuity since not many companies have the money to be able to go on multi-million-dollar business ventures for a product they do not know for certain will be standardized. And that's just for engineering, that's just for normal materials. In the medicine business, to create, research, and develop a new drug can cost hundreds of millions. So that's why the medical field also has standardizations. Of course, another problem with standardization is that when new technology is made, it tends to cause an issue of jobs being lost. So new technology always leads to a more efficient way of completing some tasks, but unfortunately at the same time means that some jobs will be made obsolete. This is just how the world works, and there is not much that we can do about it unless we completely halt forward progress, which is not going to happen. And a recent example is how AI is making huge waves and huge problems in the job market, specifically for computer science majors. So in a recent paper from the World Economic Forum, it was predicted that around 40% of all working hours could be impacted by AI, large language models such as ChatGPT-4. And the 40% that they're talking about is coders, people who code languages. That's 40% of the time on the job that they're clocked in for is actually coding and manufacturing the lines for code for their products. That's completely made obsolete now. They don't have to do that because of AI. So in total, AI has been expected to change 300 million jobs in the future, in the near future, in the next 5 years. We don't see yet how many jobs can be created around this technology yet, and only focus on what it is destroying, mainly computer science jobs, like software development, coding language professions, stuff like that. So today it seems like the end of the world, but it is possible that someday in the future, AI will be responsible for the creation of many more jobs than it destroyed. For example, in a study done by the Massachusetts Institute of Technology, MIT, it was found out that about 60% of jobs in the US represent new types of work, so work that has been created since 1940. So before 1940, those jobs didn't exist. A century ago, that computer programmer may have been working on a farm. So it is seen how many jobs have the potential to be made obsolete. However, simultaneously, most jobs in the future will be caused by new technology and advancements in engineering and sciences. The same study also says that from about 1940 through 1980, jobs like elevator operators and typewriters tended to get automated, but at the same time, more workers filled roles such as shipping and receiving clerks, buyers and department heads, and civil and aeronautical engineers. So, where technology created a need for more employees. So, it is safe to say that while it may seem that jobs are becoming automated and made obsolete, the truth is that it is natural for these jobs to slowly subside and inevitably will be replaced by two more jobs in the future. So, in conclusion, new technology will always be good for tomorrow and a nuisance for today, as our children will be able to enjoy the fruits of our labors, however, still must be diligent enough to want to create even newer ways to further humanity. We in the year 2024 use phone lines and railways and roads created decades and decades before us. Even though there was a use for building newer and better roads in the 1920s, they didn't know back then how much we would depend on cars today. Ford has a great quote where he said, "If I had asked the people what they wanted, they would have said faster horses." So that really puts it into perspective how we can't really control what the next big idea is, and we can't control how much we rely on that new idea. It's just whatever happens, happens, and once it does, that's how we have to go forward. So to be an engineer is to create, and we as a people's job is to endure. So it makes sense that so many of our systems in place are meant to last for a long time, but a long time is not forever, and therefore necessitates change one day or another. If we become too used to our systems in place, we're going to forget the importance of trying to make something better, and instead only value making something work. So the problem that needs to be faced, in not just the field of engineering, but in our everyday lives, is that we should always strive to find a better way of doing something. Us being reliant invites a lack of change. Industry standardization would invite newer technology to be created and made readily available to be used, sold, or implemented into our current infrastructure. This would be good because it ensures progress does not stagnate, fostering a culture of continuous innovation and adaptability. By embracing industry standardization as a foundation, we enable new technologies to be integrated seamlessly into existing systems, ensuring that they remain relevant while evolving with the times. So that's pretty much it. It's how standardization, we need more of it. We really do need more standardization because we need to be able to move forward as a people. Because if we don't, then everything becomes stagnant and we won't be focused on the next big idea. So thank you for that, and see you later.